Welcome guys to the June Meetup of Sri Lanka. And today we have some interesting topics to discuss. So we have Nayana Samaranayake with us. He's from Google, he's studying Google Bhagya office. And we have Bhagya. He's from the Google project they asked me and going to Google analysis. Now Bhagya will talk about his application Lanka, and he's a guy, as I said earlier, he's a guy who participated in the IMC and who won the Google Places APIIT last year. So he will display his new from the picture. I think it's the first time in Sri Lanka. He will be doing this in the first time in Sri Lanka. And he will talk about Lanka and his experience about Google. So
hi guys, for those who don't know me, I'm Bhagya. For those who know me, so I'm Bhagya. I'm a developer of June. Okay. Do you have a mic?
Sorry, you're not that technologically advanced yet. Sorry, man.
I lost a bit of a voice yesterday. Okay, so you can connect with me on this topic. So first I'm going to talk to you about geolanka.com and a bit of the Google Places API Developer Challenge and how I won it. Plus, I'm going to talk about the Google I/O experience from what I saw, and there is some introducing Geolanka. So it's a simple search engine to search for advertisements and location-based reviews. So right now, Geolanka handles information related to property and rental listings, vehicles, supermarkets, banks, hotels, restaurants, and almost pretty much everything that has an address associated with it. And it was built for fun, right? And it was in 8 what I wanted to first was to play with data, and when I didn't have data, I thought, okay, there should be a way that I should be able to gather this information. So I looked at, okay, how I'm going to, let's say you want to get the information of all the classified listings into one something. There's no API, right? So you have to make your own API. So one thing that I was able to do was to write something called crawlers and scrapers. So that can be, those can be written using Python, and I thought maybe there should be a way that I can gather and store all this information. So I started looking at ways, okay, how can I just gather this information? So one of my first goals was like, okay, you want to buy a house in Colombo 7, and you want to find the most cost-effective house, right? So if you're going to find that, you need a list of all the property listings in Colombo 7 that is available online. So I turned to a site called Scraper Wiki. So Scraper Wiki allows you to build APIs, and you can write custom scrapers or crawlers to gather the information and store it on Scraper Wiki servers. And it also allows you to access this information through a REST API. Right? And Geolanka is also like considerate about the ownership of information. So Geolanka respects robots.txt. So if the site tells that you don't crawl this information, it will ignore it. And it will only index public data available without a login. And yeah, it was basically built using Python. Google App Engine has lots and lots of APIs. You're going to see a list of all the stuff that's being used. And tons of JavaScript. Actually, right now, Geolanka has no backend. So everything you can download the Geolanka. You can go to the geolanka.com, download it on your machine, and you can run it. But because the data is hosted from Scraper. So right now it looks like this. It's actually the second UI iteration. The earlier version had a much bigger map, and the listings are on the right side. Yeah. So you can see that it already has listings from Lanka, ikman.lk, plus there are a couple of more sites with provision subscription. So I think it's a cool way you can find information if you're buying, when you make a purchase decision based on something that you're going to buy online. So to get information on Sri Lanka, you can go to these links. So in about the technology and library. This is a developer Group. I'm going to go through all of it. So Python, JavaScript, HTML, the usual suspects for search engine, and Google App Engine. So what's interesting about Google App Engine is I used it to host this HTML in Sri Lanka right now. And there will be more coming on Google App Engine because there's an upcoming backend to index the information, and it will be hosted on Google App Engine. And Memcache is used. So that's basically for a new edition that came up a couple of weeks ago. And ScraperWiki, okay. And Bootstrap UI framework from Twitter. It's really interesting when you scaffold a new application quickly. It's very jQuery UI layout. It's used to manage layouts in the new version of the app. And Google Maps API and Google Places API. So these are the most important APIs in Sri Lanka, I would say. What Google Maps API provides is the map, which is used for showing you the places where each listing is placed at. And Google Places API is used for autocomplete. Plus, it will be also further used in an next version that will be used to show you places, for example, schools. If you're looking for property listing, it will show you nearby school. So Google Places API pretty much allows you to dictate types of places around a particular geographical coordinate. And the Google Plus API, so this one was used for interesting purpose. I will explain it to you later. Google Charts API is used to generate the QR codes available in the version of Sri Lanka, and of course AdSense. It's not paying any money, so I have to tell you. And this library called the marker cluster. So this one is these ones are used for the presentation layer. Where, for example, some listings don't have exact addresses specified. So if you search for a vehicle, if something comes from, let's assume, Canada, okay? So people don't always put their exact address in all their listings. So what happens is you have to cluster all these, or say, the place markers. So mark cluster is a library that is used to cluster all these markers on Google Maps together. And this is something interesting that's called OMS, or Overlapping Markers by Default. So when you click on locate the clustered marker, which has more than one listing associated with it, what markers by default does it is it will show it like a spider. So you can actually handle more than one marker on one place. And Q.js is used for it's a querying library, and allows you to have a synchronous kind of JavaScript. So, for example, you won't get unexpected behavior when you run something, right? Numeral.js is an interesting one because, for example, in the newer versions of Sri Lanka, you will see that it will also show you price information. So price information wise, if you're showing it, you have to format it in a way that users can easily understand. So numeral allows you to convert values into text much easier. For example, if you get something like 1.4 million, it will be shown as 1.4 million format. And the Bootstrap resources are served through the Bootstrap CDN from getting this process separately, and at this used to track our user social. So I have a couple of announcements to make. So geolanka.com API will be available soon. You will be able to create apps that use the vast amount of information Geolanka has, and it will be free. Right? And yeah, it will be running on Google App Engine. And there will be another API that will come up. That is, the site administrators will be able to provide information to Geolanka when they publish information on their sites. So I don't think this will be much used, but it will be open. And if you want to build a mobile app for Geolanka, you are also free to do so. So you can talk to me, and I'll give you the access. You build your app and any apps. Okay. So Google Places API Developer Challenge. This is something that came up around October and November last year. So this was when I was playing around with the API and the scrapers. And Google opened up a challenge for this name, and they said you have to use the Google Places API and build something that is interesting, and that's something that uses civic data. So civic data is information that is presented by the government that is being made open for people to use or any organization. Right. So exciting times. I would say we were not sleeping at those times. Submissions were from around the world, and there's two categories of prizes. I would say one is the Judges' Choice Awards and the People's Choice Award. Right. So there were submissions from Brazil, India, and there were so many other countries who participated, almost more than 40, I would say. So geolanka.com won the People's Choice Award. It's unbelievable, and we got 3,900 plus votes. Right. So this was not done by myself. So I have to first thank you for everyone who supported Geolanka and voted for it. So I can show you the video that I made for it, because when you're submitting for this competition, you have to create a video. So has anyone else seen this video? Okay, let's see how that. So about reaching the public. So as I said, I wasn't doing this by myself. So I had to reach almost everyone. And one thing I did was I didn't focus on Facebook or Google Plus and it was not Twitter either. So I went to all these forums. For example, so that's where like a lot of the people who are active online hang out, I would say. And there are many other forums, plus I got coverage on one of the gossip sites in Sri Lanka. So when you got covered in some kind of like a site, especially gossip sites, I think most of the top 10 visited sites, I think there will be at least 2 gossip sites. So that after the coverage by the gossip site, sadly it is now blocked. So I'm quite sad about it. But the votes increased significantly, and people are sharing like crazy. And one other thing, when I was asking for votes, I was keeping a close eye on the campaigns, because I had the comments on the YouTube video open for people to come and vote. But there were people who were coming from other countries who were trashing it. So I built a separate dashboard using YouTube APIs, which was showing me the status. Okay, what are the most recent comments on it? And I was keeping the tab of all the top people who were getting the votes. So and the app was built using YouTube APIs and Google Plus APIs. Because the votes were done using Google Plus, I had to use that. And AngularJS and Bootstrap. So I can show you it's a kind of like secret dashboard URL that you got. And you can, I can show you now. Right? So you can see the top 4 at that time. So you can perceive Australia and India. So you can imagine if something appeared on Indian national newspaper, it would be, I wouldn't be able to catch up. Right? So the coverage, the news that I got from the media, and EU.com. So it's a very simple app. That kept track of votes every time we checked the dashboard. So I can show it to you. So I was sharing this Google Doc with my best friend who was in Bangladesh. He wasn't actually sleeping at all. So he was checking the votes every few minutes to update this. And we were chatting this. So you can see some of the competitors, their votes went up in a sudden and they all went down for some reason. But we managed to stay up. It was never people actually going like that. So on February 14th, 2013, something interesting happened. Nothing else. I won't Google it as a challenge. So this is what I wrote in my diary. So the Google Places API challenge, the winners got $2,500 for travel, plus 2 tickets to Google I/O. So I was able to attend the Google I/O, and it was held in the Moscone West in San Francisco, and there were more than 5,000 developers from around the world who attended the I/O. So I'm sure that as Google devs, you will be keeping track of the I/O, maybe more than me. So I'll be talking about the experience and all. Facebook developer is talking. He's actually my brother, so he was lucky to go with me to San Francisco. So the first day, day 0, we had the conference check-in, and we all got an NFC badge and a T-shirt. Not that one. We got a gray one with the logo. And there was a party thrown by Facebook in front of the Moscone Center. So we went to that, and I was meeting the developers of Facebook Home for Android. So the guys who invented chat heads and all the guys were there, and we got that. So when I checked in at I/O, this is what something you would notice, but it's called sensor mode. It said like, please ignore me. But it has been tracking us all. We only got to know like after the session. So I'll explain. This is the I/O badge. You get. It's actually having an NFC sensor in it. So at the I/O, if someone had an NFC phone and you tap on the badge, you will be taken into the person who's going to class. This is I/O. So the most concept of the entrance. And this is really Facebook, the people who are behind Facebook Home. Yeah. So day 1, keynote and announcement. So I think the Google Sri Lanka had the Google I/O extended in here.
1,000 people turned up.
1,000. Wow.
1,000 people. We had a hackathon. We gave away awards, and when we left at 6:30 in the morning, we still had about 350 people there. So it was an amazing success. So hats off. Yeah. Well,
350 a week online.
Because we had 40,000 attending viewing parties across the world on that day. That means 40,000 people who were not in San Francisco around the world joining, and 1,000 were from Sri Lanka. So it was a big number for us.
So at the keynote, Sundar Pichai announced everyone is getting a Chromebook Pixel, right? So it was good. And there was a very inspiring speech by Larry Page. I'm sure that most of you must have read it. Right? And actually, I missed the last part of Larry Page because I had to speak to the Google I/O extended in Columbia. So I spoke over a live hangout, so I had to run. But that guy watched the entire thing. And I went to a session where the first day there was a couple of sessions. One, I'll be going through each of them, right? So one is for making the location more meaningful with Google Maps. That was about the upcoming API features and the Maps plugin add-ons that are coming up. And there was 7 technicals and a microphone that was about how women are empowering technology and how they are going to change the world as usual. And it was really inspiring. And there was the Google I/O after the house party, and there was augmented reality stuff and robot fights, robot bartenders. So you would ask the robot what you want, and the robot would make it. And there was performances by Billy Idol and Steve. And yeah, on the keynote, something interesting by the speech by Amit Singh from he also speaks about that. the footsteps of the MRS, all places. So yeah, there's a couple of pictures that I took. This is Larry Page. So this is Larry Page. And this is what I got. So this is actually the small Android Flash toy. Nothing you have yeah, it has a small logo. And yeah, now you can see it's the development purpose is on. So these are the photos taken. And him playing boxing with the robot. Yeah. The second day, I attended a session for developing the Google Glass. So Timothy Jordan, who was a senior developer advocate for Google Glass, was speaking at it. So he was demonstrating the new features and gaps that are made available for Google Glass. And he also, at the time, he announced the Twitter and Facebook apps for Google Glass. And I went to another session called Hands-On. A new Google tools for handling structured data. As developers and people who are working with the data, I think it's going to be interesting, and plus for webmasters. Because right now, Google is, I don't think they need much structured data. So for example, WebSearch has one. So you can't actually search by faceted search, say like by price and stuff. Unlike Lanka, Google doesn't have that feature. Right? So one way they're going to address is by introducing some and promoting semantic markup for existing web pages, and to encourage masters and administrators to mark up this content using their newly introduced Google structure. Google highlighted. They have introduced a highlighted tool where you can actually take your web pages and train their machine learning algorithms to identify the structured data that is available on your site. For example, if you're running a site which has events, right? So Google will be able to identify the start and end dates of the event, the location, if the site, the event needs to, if it events is an open event or event that you need to buy tickets, and make search results based on that. So you can, it's going to be part of the conversational search and the announcements to Google search, where you can ask, okay, Google, what's happening today in Lanka? So it will say, okay, Google, I will just do this. Right. I think it already does Google Plus. So the progress from class is taken into search now. I think I'm not sure. So it was done by Josh Ain and Justin Brown. So those guys were working actually at something called ITA software, which has been acquired by Google for their flight search and semantic stuff. So they had actually had a product called Needlebase. So Needlebase was a system where you can train algorithms to extract semantic data, just like Google Semantic highlighted us. But Google closed it down, so you can't do it. And there was another session about building developers.google.com website. I know it's a massive website, and lots of developers visit it. I'm sure that most of you have at least one visiting. Yeah. So about how to manage the transactional integrity and how, while you're uploading new pages on developers. I think most of the sessions will be available online already. So day 2 again, Dart language. How many of you have read on Dart? This one. Yeah. So it was about Dart. It's a Google language that they are going to introduce us. And there was a session by Joe Marini, who authored the first book on document object model. So he's actually working at Google, and he was talking about upgrading your existing app onto a Chrome package. So it was really interesting. You can find the session on Google. And behind the data sensing lab, gathering, processing, and analyzing data at scale using Google Cloud Platform. This was done by Amy Undu and Kim Cameron. So they were talking about actually how those innocent sensor modes have been tracking us. So they actually had these sensors almost more than 900 sensors around the floor, and they were real time feeding it to Google compute cloud and gathering statistics and showing information. So they were able to tell, okay, this conference room is okay, the temperature and the humidity is going a bit up. So this is probably, the conference room is almost full, or it's generating more heat, I would say. So the application was actually online at the time, so you can visit it. So go to Google I/O Sessions site once after you go today, and check out the sessions, and they're really interesting. So it won't be much different than what I experienced. So you can give them a lot of knowledge on what they are doing. And day 3, I didn't attend much sessions, and it was mostly spent for networking and going through the books, you know, playing with the glass and stuff. Yeah. So the next thing I will talk about is this. So this is about the Chromebook Pixel. I'm not going to go into specs because it doesn't matter. Right? And it has it's got a gorgeous display, and it's made for the internet. And it comes with 1 terabyte of Google Cloud Storage, and since it's built for the internet, it has no gaps. No, of course you can understand. And maybe. So, okay. The other interesting thing about this is that this is actually having touchscreen, so you can actually interact with this device. So there's a guest browsing mode available on this. So if you want to log in and do some, you can use that. About other things, you can actually, for developers, you can't really build any Android apps on this because this is not running in real OS. No, sorry, it's running Chrome OS, but it's almost a browser, so you get so on Chrome OS you can use additional IDs. Maybe you can use an online ID like CodeNV or nitrous.io or whatever, and then put it to GitHub and use a virtual machine to compile it, and do magic. Yeah, and this is a developer edition, so you're supposed to build apps on it. So I have not found a way to run anything else. But a lot of people hacked this at the live conference itself, right? So they ran the Ubuntu on this. It's actually available already. So there's a tool called Proton, and you can install the Ubuntu on this and use it for development. And it almost runs side by side. So you can actually change the Chrome OS back and forth easily. Plus, I mean, the first thing you notice about it is display, right? And how very well built it is. And it has now its host port, as most laptops do. It's very thin. And there was 2 editions that were given at the I/O. Since you're more interested in details as developers, so I got the one without the TV. So they were giving away the TV edition for people who were from the US, and it was locked on the US. Yeah, and it says so. So I'll be having this, so you can have a look at it. I'm not going to pass this. Yeah. And all the apps are running inside the good thing about this is all the apps are running inside the Chrome sandbox. So that means you are pretty much safe from viruses, and most people are scared. They use it. And you can get actually, the device can be updated through different channels, stable, beta, plus dev. So you can change the update channel by going through the browser. And right now I'm on the beta. So you can go to the URL and there's a terminal. Interesting. The best thing it can do is it can ping. So nothing else. Because you don't have files. So what you can do is whenever you just code called downloaded. But once whatever you put it in downloaded goes downloaded. Everything else goes to Google Drive. So because of that, and this only has I think 32, right? This only has 32 gigabytes of storage. But it comes, interesting thing is that it comes with 1 terabyte of Google Cloud storage. That's for free. Yeah, so after 3 years, maybe they discontinue something. I mean, we can be optimistic because Google Plus had less storage when Google I/O began, and after the keynote it had like almost access storage. Plus after stuff it was announced, I think it came up with 1 terabyte storage. So Google Plus. So I'll take you for a couple of photos. Yeah. So this is Timothy George, he was explaining about developing for mobile apps. So actually, I think it would be really interesting to develop some glass standard outside units. Otherwise, I could have probably tried to bring it down. Just kidding. Right? So it's very simple. But the thing is, you can't directly talk to glass. You have to call through something called a mirror API. And the other interesting thing is, you can simulate mirror API already. So, for example, if you are interested in using for glass, you don't have to wait for it. So just go and look at the mirror API and imagine things that you can do with it. Because not having a glass is not going to be an excuse if you are developing for glass, because it's at this stage where things can change rapidly. So if you make a horoscope app for glass, it will be the horoscope app for glass. Right? So especially when it comes to emerging ecosystem, platform ecosystem, it's better if you can enter as early as possible. I actually met a guy who had a horoscope app with more than 1 million downloads at the APIIT party. So actually, almost all horoscope apps have a very high rating. So if you go and check out, I myself have more than 3 horoscope apps. So I was telling him, oh, I have 3 horoscope apps, but how is it? And this is glass. Up close, so I'm sure that you have seen enough. And this is really very good class. I think this is in Spanish, right? Yeah, so this is the dinner with the Google Places API Challenge winners. So as part of the award, we had it really nice. We were invited for a dinner. So along with the people who were building Google Maps, and the winners of the challenge, the challenge choice award. So this is the floor, the second floor of the school, where the Google Plus was. So I think Google Plus is going to be very big. They have a lot of plans for it. You know, I'm sure that you have seen the photo editing tools like Photos and stuff. And this is me. And this is me at the Google Class building at the Google campus. So, if you have any questions, you are free to ask now. Do you have any questions?
So you picked the Google Glass. So I'd like to know more about. So how was the feeling? How was the experience? So
it was awesome, and you see, like, okay, in Moscone, interestingly, when we were walking to get our passes to I/O, it was like people who were walking and like. Okay, so they were tapping, and it was a new experience. For me, wearing it personally, it had a clock. And when you tap on it, it shows up a menu saying OK Glass, the time and the OK Glass. So if you spell out OK Glass, it will show the stuff that Glass can do. So interesting, the most used feature is that to take a picture functionality. So OK Glass take a picture was almost everyone studying with that, right? Apart from that, it has a timeline-based navigation. So it would feel as like, have you used it in BlackBerry? So BlackBerry has a small navigation key where you can, it's an optical sensor which is used for like, so you get kind of like the same feeling when you are the glass touchpad, so you can navigate back and forth, and it feels really intuitive. It's surprising, and it's like looking at a, I would say, 60-inch television from here. Yeah. But it's not active, and it does not get in your field of vision. Any other questions? That's really hard question. I'm not going to answer that. One of the interesting things was like me and my brother was at Google campus and Sundar Pichai was cycling behind us. Yeah, and when he was going down an elevator, I mean Singhal was behind us. Behind him. So he actually gets more popular. Yeah. Interesting, it was interesting. She means like people who are working on the Google semantic highlighter tool. So I actually had luck to them come. They do, and I was talking about them more stuff. That's on Google Cloud Platform teams, introducing the Google computer. That's what happens fast. I think the battery is telling me to go. So I'm giving the idea of like how to use how OpenShift does it. It's possible to do that in computer. So you can easily install apps which are already packaged. And the last. Yeah. So no other questions? Yeah, you can talk to me after the event. In interesting to show you. If the battery does not go off,
I'm from China.
I met all
from
New York, Armenia, London. So you're in San Francisco, California.
It's great. It's exciting, actually.
And the interesting thing was you had to queue, like the queue was so long.
610.
It's really not about us. It's about you, developers, who are building the most amazing and magical experiences that make those platforms and services come alive.
I always walk away inspired to do more. Welcome back to Developers Live IO 2013.
We are in the middle of one of the most pivotal moments in personal computing. At the heart of this journey is the impact we can have on people around the world. Android started with a simple goal of bringing open standards to the mobile industry. Today, it is the most popular mobile operating system in the world.
Google Play has just crossed 48 billion app installs. We're here to show that we're listening. And we're here because we really want you to thrive. Today we're announcing a new family of APIs built specifically for game developers, not only on Android, but also for iOS and web. So you can have lots and lots of gaming experiences, which I think is pretty cool.
So what if I want to know what this layout looks like on different screen sizes? Let's take a look.
We're now going to use our new app translation service, professional translations, directly in the developer console.
Chrome started as a simple journey to make the web much better, both as a platform for developers and as an experience for users.
Browser's a means, not an end. And so we're always trying to figure out how to make the browser smaller and faster.
Our goal with the Pixel was to get it in the hands of developers so that they can build the next generation of web experiences.
I think the best thing was always being able to talk to engineers.
Everything is very, very exciting.
Google just is innovating at such a blistering speed, it's incredible. If you are actively involved or very interested in anything that Google does, this is where you need to be.
Well, the interesting thing is we all are here to make the lives of people better. Right? So go ahead and do it. Don't afraid to go ahead. So that's what I would say. Thank you very much.
must have experienced the real Google I/O in Sri Lanka as well. Even we had in Sri Lanka, we had all the things other than the Chromebook Pixel. It's a semi-Moscow. Even some Google said that it's like the sorry, the mini Moscow. So Sri Lankans got that chance. A lot of guys. So and as Rohan said, we have to thank Movidel Sri Lanka, and also Google Sri Lanka for making that.
So I got a couple of stuff that's to give if someone is using YouTube APIs or AngularJS, just talk to me.
Nice.
I'm really happy to see a lot of other GDG managers in that video. There are some people from London, Brunei, and people who are from GDG. And okay, so let's move to our next session. Before introducing him, I'd like to say this. As IT and computer science students, we must know one person. I think he's played Professor v.k.Samaranayake. So Nayana is his son, one of his sons. So apart from that, he is one of the pioneer members of Central College. So you guys might know him through that Central College. And apart from all the things, he has worked for Google for more than 8 years. And he is working for the WebSearch team. And I'll ask Naya to do his session.
Okay, so I'm going to give you guys kind of an overview of how WebSearch works. So I normally go into a lot of technicalities, but I don't know what the crowd here is. So just to get an idea, is everybody from a CS background? Does everybody have a CS degree? Nobody has a CS degree? Okay. 2 people? Okay. So I normally go into a lot of technical details, but I try to keep it at a higher level. So basically what I'm going to talk about is how does google.com work, what happens behind the scenes. So you guys are used to going to google.com, typing a query, and magically you get 10 results plus some other information. So I'm going to talk to you about how we do that and how complex that actual process is, even though it seems like it happens in a blink of an eye. So there are a few main parts of WebSearch. I'm going to first give you guys kind of an idea of like how WebSearch evolved, and then I'll talk about the 3 main components of serving the web, which is crawling, indexing, and serving. So those are like the 3 main components, and then there's serving has quality and also some other parts. And then I'll also talk a bit about spell correction and how we do things like that as well. Just before we start, how much time do I have? Okay, so before I start any presentation, I have to give out our mission. Our mission is to organize the world's information and make it universally accessible and useful. So, how many web pages do you think are on the web? So let's just focus. So, our mission is very, very broad. Our mission is very, very broad. It came up in about 1998, but the founders were visionaries that they didn't want to think of something small. They said, okay, let's organize the world's information. Rather than saying, okay, let's just organize all the web pages. And there weren't too many web pages at that time. So how many web pages do you guys think there are at the moment on the internet? Any guesses? Not you though. Come on, guys! You need to talk, because I like to have a kind of an interactive presentation rather than me just talking and you guys like pretending to listen. So
Throw numbers. Come on now.
So any numbers, just throw out numbers. Don't be shy. 15.
There's a billion over here.
Billion.
There's a billion over here.
There's 15 billion here.
There's
Anybody
15
else?
billion over there.
Going once, going twice.
Going 40 billion.
40?
40 billion.
Still try higher. Go up, people.
100 billion. 100 billion.
100 billion.
100 billion. Sorry?
1,000 billion.
Wow, good job. Technically there are 1,000 quadrillion pages, but if you actually think of a notion of useful pages, it's going to be less. So if you're thinking of the notion of useful pages to some extent, it will be about 1 trillion pages. So technically you can actually generate as many pages as you want, because you just need to go to a site with a form and just keep putting different numbers, and you'll get pages for every number you put in, right? So technically you can generate as many as you want. But if you think about somewhat useful, and when I say somewhat useful, I mean like your home page or like some blog that you write, those are all useful, so somewhat useful. And if you consider all those pages, you have about a trillion. So to give some perspective, the Milky Way has about 300 billion stars. So the web is much bigger than the Milky Way. Your body, your nervous system has about 100 to 200 billion neurons that communicate. So it's much bigger than your nervous system in the human body. So it's a very, very large space. And in the WebSearch group, we work on how do you go through all these pages and how do you return answers to you guys within a few hundred milliseconds. So to give a bit of history, this picture up here, this is from one of the Stanford labs where Google initially kind of started. It used to be called Backrub because it used backlinks to kind of rank things. And it ran on a few machines, so it was kind of a distributed system at that point as well, to some extent. So how many of you guys have written a distributed system? Have you guys written a program that runs on more than one machine? How many machines have you written? Couple, 2, 3, okay. So yeah, so at the beginning it was running on a few. Then we moved on to these. This is one of the first production racks. So this rack had about, I think it had about 12 machines altogether. So it was serving basically Google.com. And so one thing about Google is that from the beginning itself, we were looking for cheap hardware. We didn't go and buy the biggest mainframe or biggest, most expensive server. We were going to kind of the corner electric store, the electronics store, and getting like the cheapest hard drives we can find, the cheapest memory chips. So the idea was that you don't want to spend too much money on the components, but you want to actually have redundancy. So if your hard drive fails, you would have redundancy such that you fall over to another hard drive and you have the data backed up. So as you can see, it was a cheap operation. Like everything was made by the founders. They would like solder the boards together. And I don't know whether it's clear here, but when they put these racks, machines in the rack, so we call these trays. Each one is a tray. They realized that the things were touching each other, so you can see them bending kind of because of the weight. So they were not like, properly designed in a sense. So they were touching each other and they were short circuiting. So they actually put corkboard, so you can see the same material you have in wine corkscrews and all. So they put it in between as a to kind of insulate the two trays and make sure it doesn't short circuit. And at the bottom right, that's kind of the first Google homepage. At that point, we were serving like 25 million documents, and this was kind of during the time that I think was running out of Stanford. So search has evolved. At the beginning, you just got 10 links, and you'd search for something, you kind of get the best 10 links, then you have to go to these links, try and figure out what information you wanted and see whether the information was in there. But over time, we've kind of evolved and we are trying to understand the user better and better. So when you ask a query, we try to understand what you mean by that query. For example, the top right, the query is things to do in Sri Lanka. And we know things to do in Sri Lanka means you are interested most probably in tourist attractions. So about a year and a half ago, we acquired a company called Freebase. And they had this database of entities and their relationships to each other. So from this data, we can now identify that, okay, if we know that your query is asking for tourist attractions, we can look at this database and we can say, okay, give me all entities related to Sri Lanka through the predicate tourist attractions. So we have this graph and we kind of traverse the graph and we get information. So that's how we kind of give all the popular attractions in Sri Lanka at the top. And then we know that the main topic here is Sri Lanka. So we use this knowledge card on the side that will show Sri Lanka and the most frequently accessed data about Sri Lanka. search has also evolved in other ways. You can search by image. You can drag and drop an image, and we will analyze the image, and we would return similar images. You could search by voice, so you can just talk to your phone or to your computer or to your glass and say things to do in Sri Lanka rather than typing it in. Especially in an interface like glass, it's much easier to talk rather than type. There's no place to really type in glass, so search is evolving in that sense as well. So now I'll kind of go into the details of how all this happens. There are three main components, like I mentioned. There is crawling, then there is indexing, and then there is serving. I'm going to talk a bit about crawling and indexing. I'm going to mainly talk about the serving side, but I'll need to give you some ideas about how crawling and indexing works. So we have these trillion pages on the web. How do you build a system that actually searches? The first step is you actually have to crawl this data. You have to go grab this data, and you have to process the data. So to grab this data, you would actually go visit the websites, and you would actually download a copy of the site. So Google pretty much has a copy of every website on the internet, and then we kind of do the processing on top of that. To go and grab these pages, you have to do something called crawling, which is done using something called spiders. So spiders are these bots that go around the web and download the websites to do the search. So we do this by identifying seed sites. So you start with maybe a few 100,000 seed sites, and that's in some database. And then you go to that site, you scan that site, and then you look for all the outgoing URLs from that site, and then you add that to your database. So you keep doing this, and then you slowly grow your reach, and you kind of spread out the internet. But there are a few problems with this plan, because there could be islands in the internet. There could be certain sites that are not connected by outside world. It could be your home page, for example. Maybe nobody's connected to your home page. Maybe you just launched your home page. So how do you actually get to these pages? So there's something called Google Sitemap. So you can go into the webmaster tools, and you can say, okay, I have a site. These are the pages in the site. Please go ahead and crawl my site. I want to be on Google Index. So that's one way of getting it. Another way is sometimes hosting providers and domain providers, they would actually tell us that, okay, these sites are around. You can go ahead and crawl it. So when we are crawling these, we also pay attention to robots.txt. You was mentioning robots.txt. You need to that's kind of the rule of law in the crawling space. So robots.txt basically says what can you do and what can't you do. So it might say this part of my site is not for crawling, it's not for public viewing. It might also say different things like how often you can crawl and specifics like that. So we tend to adhere to those rules. You don't want to, in case you're running your website from a server at home, we don't want to be heating your server all the time and downloading everything on your server to our machines if your bandwidth is limited and your upload bandwidth is limited. So people might get really pissed off if you hit them too often. So we want to adhere to those guidelines. And another important part about crawling is that you need to crawl for freshness. So your homepage might get updated once a month, once a week, maybe once a day if you guys are very, very enthusiastic. But CNN.com, on the other hand, would get updated every few minutes. So we need to identify, okay, this site is getting updated a lot, it has relevant information, so we need to crawl it more. So we need to make index selection decisions on which sites to crawl more often and which sites to crawl less often. So all of these things are part of crawling, and crawling is a big part of the whole serving system. We have thousands of machines working on going and grabbing this data and processing this data and making it ready for the next step, which is indexing. So indexing at a very, very, how many of you guys have done an information retrieval class? Okay, so I'm going to give a very, very high level idea of like how things work. So when you get a document, we pretty much have a list of tokens. You can think of it as a PDF document. So you basically have a list of terms, and what we need to do is we need to convert this document into a format that's easy to answer your queries with. So what we do is we build something called the inverted index. So rather than having document and the list of terms, so if you have the document and the list of terms, the problem is that when you search for a certain set of terms, we have to go through all these trillion documents, and we need to figure out which ones have these terms. So that doesn't seem too efficient, right? So what you want to do is you want to build something called an inverted index, where you take the terms and you make something called a posted list that says this term is in document 1, document 5, document 10, and so on. So then when you search for something like Sri Lanka, you can go to the term Sri, figure out the list of documents, go to the term Lanka, figure out the list of documents, and do a simple intersection. That's much, much more efficient than trying to go through all the documents for each query. So how many queries do you think Google gets per day? Roughly. Any guesses? How much? Millions? 5 million? 5 million? 3 million? 1 trillion? Who's in the trillion? So we actually get more than a billion queries a day, and out of these billion, more than 15% of them, so that's 150 million, are queries we've never seen before. So hard to believe, right? Like people come up with random. Yeah, so there's a lot of uniqueness in this space. So it's somewhat like hard to predict also what people will ask for from the index. So some of the so that's basically that was indexing. So you basically build this structure called the inverted index, which will help you answer the query, and it's much more efficient than going through every document. So we first build this offline. So all this happens, crawling and indexing happens completely offline. So we continuously do this processing, and then we push the serving index, we call it, into the serving clusters, where the systems will actually talk to the serving index when they are answering your queries. So all the other stuff that I covered happens before you actually ask your query. And serving is basically the part where when you type in your query, stuff that happens is the serving side. So there are different types of queries that we get at Google. Just to give you a rough idea of some of them, there could be single word queries. So the most popular queries are like single word, 2 words or 3 words. That's pretty much the bulk, and everything else is kind of tail. You might get URLs, so you'll be surprised. A lot of people think the Google text box is actually the address bar in the browser. So they just type URLs, and you get a lot of those. And then you get like a few words, maybe sometimes song lyrics. So somebody might just cut and paste a sentence from like some sort of song lyrics into the modified thing, where you can find the whole lyrics or something like that. So we get a lot of those things. And then you get complex queries, mostly asked by webmasters to kind of understand how much coverage of their site is there, and things like that, of competitor sites and things like that. So you might do a site colon or some other operator like that. And, yeah, so like I said, we have 3 actual parameters that we want to look at when we are building a serving system. There is latency. You don't want your searches to take too long. I mean, if it takes 5 seconds, nobody's going to come to Google. They'll go to Bing most probably. So you want to make sure that things are really fast. You want to make sure you have enough throughput, because you're serving more than 1 billion a day. So you need to have systems that can actually handle all this. Billion queries is a lot. So you need to build systems that can run really fast and efficiently to service also. And lastly, you have quality. You want to make sure that your top results are actually relevant to your query and are the best results for the query. Because otherwise, again, nobody will come to Google.com. The results are not good. So just to give you guys a perspective, like 100 milliseconds. How fast do you think that is? 100 milliseconds. Don't tell me it's 1 second divided by 10. But just to give you some perspective, if you blink your eye, it will take about 100 to 150 milliseconds that time. So basically, in the blink of an eye, we will return your results. We will search all these trillion documents. We will rank the results, and we will present it to you within pretty much like a blink of an eye. So that's how fast we try to get the results back. And we've actually done experiments that show that if you wait for 2 blinks of an eye, people are not really that happy. They actually kind of feel this. Like, it might seem like, okay, 150 milliseconds or 300 milliseconds, no big deal. But actually, like, experiments have shown that these actually big deal. So we try to keep our latencies as low as possible. So where does this all happen? It happens in places like this. There is a picture from, I think, Iowa data center. That's kind of a new data center. So you can see racks and racks and racks of machines. So each of these, so there is like multiple racks here. Each rack would hold about, it's either 24 or 48 machines depending on the machine configuration. And everything is connected with high bandwidth, machine to machine. So there's a mesh network. And yeah, as you can see, there are many thousands of machines in this data center. So we actually build the data centers ourselves. We also build the racks. We build our own networking gear. So we build our own switches. We don't go by, like I said, we like cheap stuff. So we buy cheap components and we put it together and we build our own stuff. And we don't really like to deal with vendors because sometimes you can't program your switches and all. You have to like go through their APIs and all. Sometimes they take too long to fix stuff. So it's easier if you do everything by yourself. And it's much, much cheaper. So we used to use something called a force-10 switch in these data centers. And basically we had multiple of those switches. And one switch would cost like $500,000. So like that's a switch that had like about 1,000 ports. And like, yeah, so 500,000 is kind of expensive. And the data center like this would require like many of those. So yeah, we build our own stuff. And it's costly for this. So, okay, so you have those data centers, you have thousands of machines, but how do you serve an index out of thousands of machines? How do you actually write a distributed program to do this? So we use some technique called sharding. This is again a very basic technique in information retrieval. What you do is you take this whole set of data and you break it into smaller chunks. So for example, if we had 1,000 machines, what we would do is we would take this whatever trillion pages, and we would break it into a trillion divided by 1,000, which would be a billion pages each. So we would say each machine would serve a billion pages, right? So, but then how do you kind of handle the query? So every query will actually hit 1,000 machines there. So at the moment in Google.com, when you search for a term or a phrase, it actually hits many thousands of machines before you get the answer. So within this 150 milliseconds, we are hitting thousands of machines. We are getting bits and pieces of your answer, putting them together, doing all the ranking, and returning back to you. So in a simple example, if you have 1 million documents, let's assume you have 1 billion documents, and you have 1,000 machines. What you do is you say, okay, each machine will have 1 million documents, and we do something called mod sharding. So what we do is we take each URL and we do a fingerprint on this. So we basically run a hash function on the URL, so you get a numerical value. Then we mod this numerical value with the number of machines you have. So if you have 1,000 machines, we take this numerical value for a document, mod 1,000, which will give you an answer from 0 to 999. So that number, that result, is the machine that this document will go on to. So you do this for all billion pages, and then you have roughly about 1 million per machine distributed, because it's a random hash, so it should be evenly distributed. So
frequently use searches, is there any mechanism to avoid
yeah, so we have caches. So caching is a big thing. I'll get to caches in a bit, but we cache a lot of data. It's very important part of search. So now you basically have, each machine has 1 million of these documents, So each query goes to each machine. Each machine finds the answers for that million documents. And then there's a root machine. Each machine returns the top results to the root machine. The root machine kind of figures out, okay, out of all the returned results, which one should I send back to the front-end UI? And that's kind of how your query gets answered. So it's a lot of work happening, even though it happens really, really fast. It's a lot of CPU power behind answering each query. Yeah, so how do you handle resources? I don't think I'll go too much into details here because you guys are not hardcore CS. I think hardcore CS are like systems people. But yeah, pretty much you have like different components in a server. So you have your memory, your network, your disk. So each component has different latencies. So memory is really fast, but disk is really slow. But at the same time, memory is very expensive, whilst the disk is much cheaper. So you want to kind of work on the trade-offs. Okay, where do you put your data? How do you access it? Do you compress data versus do you not compress it? Because if you compress it, the size will be smaller. But if you compress it, that means you have to also decompress, which will cost you CPU cycles. So there are lots of trade-offs here. So understanding these trade-offs are key when you are writing a distributed system and a system at this scale. You need to know all these numbers, and you need to know how to lay out your data such that you get the most efficiency out of your system. So I'm not going to go into these tools, but actually on caching, I'll talk about your question. So yeah, so I talked about 15% of the queries we've never seen before, but at the same time, there's a large chunk of queries that we see very often. I mean, things like Barack Obama, Sri Lanka, so you get these frequent queries. So there's no point, to some extent, searching over and over again for these queries. So we actually have caches that will store the results, and the next time somebody asks for the result, for the query, we will actually return the same result. But at the same time, we also need to pay attention to freshness, because the web is changing constantly. So something like Barack Obama, you can't like cache it and keep it for days, because the news and the results will be changing day by day. So you actually need to refresh your caches. So we have something called a TTL, a time to live, for each cache entry. And once that TTL expires, you will redo the full search and you will refresh your caches. So even though things are happening frequently, you will still be querying the system. So it's okay, so to move on to quality, how does ranking, quality, and all that work? So at a very, very, like a 10,000 feet kind of level, give you an idea how quality works. We look at how many terms are there in the document, like are the key terms that the person is searching for, are they in the document? Are the synonyms in the document? We look at bigrams that might be more useful than just a term. Then we look at where the term occurs. Does it occur in the title? Does it occur in the URL? Things like that. And then we also have signals like PageRank. So how many of you guys know PageRank? What PageRank is? So PageRank is one of, so we have over 200 signals that we use in ranking. And PageRank is one of the old signals. It's actually being kind of replaced by a new signal, but what it does is it looks at all the people who are pointing to your site, and based on the importance of those sites, it kind of gives you a rank. And it's a system that we run in iterative sense, and basically the numbers converge after a certain number of runs. So then you kind of get this quality value for each website. So we've, how many of you guys have heard of the Panda algorithm? Anybody? And so we recently, about a year and a half, or two maybe ago, we did this Panda algorithm. So that's another quality kind of signal that we use to figure out like which sites are useful content versus not so useful content. Like sometimes people just cut and paste stuff and put in and kind of create a new site. So kind of try to identify things like that. So how do you actually come up with these ranking signals and all that? It doesn't really come out of do, like it's not like you wake up one morning and say, oh, that's a good signal, or this number should be something. But Amit Singhal, he's like the head of search quality. He's I think the only person who has the intuition to say, oh, I think this number should be like 2.7, and it actually works. So, but for the rest of us, we kind of go through this whole thing, where you kind of come up with an idea, then you implement it in a sandbox, so you kind of implement it internally, and you run something called side-by-side. So side-by-side is you have your baseline and your experiment, and it shows the results basically side-by-side. And then you kind of look at those results for some query sets, and then you can kind of understand, okay, is this signal actually adding any value? Is it positive, or is it neutral, or is it actually negative? So if you feel like it's kind of positive, you would send it to raters. So external raters, we have people who kind of, their job is to look at these two sites and say which side is better, and they go through thousands of queries. And so they basically give you a rating. And after they give you a rating, if it's still positive, what we do is we run something called a 1% experiment, where basically 1% of traffic in one data center is running your experiment. And so you might have made some change, so that when you search on google.com, the results are coming based on that experiment as well. So you might not know it, but when you're searching, you might be on an experiment, or you might be on like the regular production setup. So based on this 1%, we actually kind of measure key signals like click-through rates and like long clicks and things like that. And based on that data, there are analysts who look at the data and come up with a report saying, okay, this is the final report for your experiment. These are the metrics. And then you like kind of look at that those results and see that, okay, is it still positive? And if it's still positive, then it goes into a committee review where the committee decides, okay, should we launch this or should we not? And that's kind of how things work. And if the committee thinks that certain things have to be changed, then you kind of go back to the drawing boards and you kind of keep doing this process. Yeah, so that's kind of that kind of covers at the high level how the serving systems work, how we go from crawling, indexing, and then how we serve. But that's not all that's required in some sense. A lot of times people have trouble spelling. So how many of you guys have typed something wrong into google.com? Google has corrected it. You don't have to be embarrassed. I mean, I use google.com as my spell checker. I just type something in and then see what it fixes into. So we do spell correction, we do synonymization and stemming. Again, this is a very basic step in information retrieval. So if you, for example, search for car companies or car rentals, we will also search for cars, automobiles, and like different synonyms. And we'll stem the word based on what you typed. So we don't want you to type all the possible combinations. We want to do that work for you. Because webmasters wouldn't also give us all the possible combinations for terms. They might sometimes be talking about cars by using automobiles rather than the term car. So we try to make sure that we do synonymization and stemming. Then we do suggestions. You don't want to sometimes type, especially on a mobile device. You want to give the user the opportunity to kind of type less. So suggestions is another thing that we do. And related searches, I don't know whether too many of you guys have used it, but at the very end of the search results, you get potential related searches based on query logs and query sessions. So how does spell correction work? So at Google, everything is data driven. We have tons of data and we love our data and we use our data. So in the old school way, spell correction was done using something called edit distance and basically having an dictionary. So you basically get these 100,000 words or whatever that you know are correct words, so you might just get it from a dictionary or something. And then what you do is you take the user's query term, the term that they're typing, and then you try to find the closest match in the dictionary word set to that word based on this edit distance notion. So edit distance is how many things are incorrect and how off they are. So based on this, you would then suggest the correct answer. But this doesn't really work in the world of the internet and the web because there are so many new terms, like people come up with new words that get coined. I mean, Webster and all these dictionary companies don't have time to kind of keep up, right? So you need to actually keep up with the, know that it's some new thing like Gangnam style comes out. You need to know that Gangnam style is actually correct spelling, not some random thing that you correct or something else, right? So how do we do that? And just to give you some perspective, how many of you guys have tried to search for this video? Actually, it's very hard. I still can't get it right. I still mess it up. So we've seen over 800 variations of this. You might wonder, like, how can you get 800 variations of this? But yeah, we've seen 800 variations. So it's pretty crazy. People type the weirdest things. Like, people have the weirdest sense of spelling. So how do we actually fix these problems, right? How do we understand that when somebody spells it wrong, how do we know that they're actually meaning that when they're typing this, right? So context is very important here. So what we do is we have all this data. We have query logs, query sessions and all that. So we know when sometimes people type the wrong thing, then they fix, they type it again in the next query, they fix it. So that's one signal. Then we could actually look at web pages and kind of get a sense of like what are the occurrences of these misspelled words versus the correct spelling words, correctly spelled words. And we can also look at, for example, if you take coffee and naan, you would see that, okay, if it's a correct spelling, okay, all good, no issues. But then if somebody spells it like this, we know based on context that a naan never happens with coffee, the thing you drink, but happens with coffee, the person, right? So then we can kind of build a probabilistic model based on like bigrams and different other signals to say that, okay, if it's followed by this word, then this has to mean the person is meaning something related to the person who was the UNN. But if it's followed by shop, then our models will basically say that most likely the person was trying to say coffee shop. So we can use context and all this data that we have to kind of build models and understand what people are trying to do and correct them.
Excuse me, I would like to know more deeper things about those things, like what are the algorithms and
so I'm very careful when I'm talking like this because I don't know what's confidential and what's not when I'm diving deep into things like that. But the best bet is like, I mean, we normally publish papers on things that are like publicly visible. But I mean, this is a very this is not kind of a new area. This is something that has been researched for a while now. I mean, when we started doing this, it was kind of new in about 2004, 3 or 4. But now there should be a lot of literature out there. So if you search for like building models for spell correction, I'm sure you'll find data. You can pick me if you can. Yeah. So, and the other part is we also want to make life easier for you. We don't want you to we don't want to just give you 10 results and say, hey, go figure it out, kind of, right? So we want to try and give you the answers if possible. So this goes into the semantic web and all that stuff. We try to understand web pages. We try to do a lot of kind of understanding patterns in web pages, try to extract data, kind of structured data out of web pages, right? So for example, if you type in Barack Obama, how old is Barack Obama? We know you're asking for his age. So rather than pointing you to a website that will most probably say he was born in 1961, and then you'll be like counting your fingers and saying, okay, how much old is he now, right? So we'd rather give you the answer directly, right? That makes more sense, right? So this is something we are doing. There are multiple projects. So we're using the company I mentioned that we acquired, Freebase. So they have structured data. Then we also try to extract structured data from unstructured websites. We try to extract it from Wikipedia, things like that. So we're building this big structured data set that we can answer things like that. Then if you say Steven Spielberg movies, again, you don't want to be directed to IMDb page or like some Wikipedia page with a list of other URLs. You would rather see nice images and the names of the movies and all that. So we try to do that because we know the intent of the user is to actually see the list of movies, and we try to cut down on time. And then if you want to call Batman, you can always put in a query into a search box, and you can get our graph widget to pop up, and then you can get the bat symbol. So we try to help you in all ways possible. Yeah, so that's kind of all I had. But I'll be more than happy to answer any questions you guys have. If you have any questions.
Can you tell some details about how you back up your data and how you keep them secure?
Back up which data? The web data? No. I mean, web data doesn't need to be secure, right? It's public data.
Cache data.
Sorry?
Cache data.
Cache data as in
web pages.
Yeah, but the web pages, they are anyways public data, right? I mean, anyways, they are safe in the sense they are within our internal systems. So we have very, very strict, I mean, people outside can't really access them. We have two-step authentication, and we have like a lot of other layers of security. So it's not really something you can get into. Yeah, so I mean, if you are logged in, your personalized search will kick in. That's one way. Otherwise, it's based on browser cookies. But mainly, it's based on like if you're logged in, we will basically understand. Okay, for example, like Google Now, right? Google Now works on understanding like your behavior patterns and all that. So if you opt in and you say that you want to share your data to get better search results, then we will use that data to give you better search results. Yeah.
Can you explain a bit more about image search? Google image search?
Yeah. What about image search?
As in how it works?
So image search works at like different levels. In the old days, we didn't really do any kind of image processing. We didn't try to understand objects in the image or anything. So it was purely on what text was around the image. Like if the image was embedded, like what text was attributed to the image and things like that. Image name. So image name might be Eiffel Tower or JPEG, and it might be the Eiffel Tower, right? So those were kind of the signals. But now we try to do more than that. We actually analyze images and we try to identify objects in the images. So if you search for Eiffel Tower, we can actually get even an image that wasn't marked as Eiffel Tower. We can return that because like the image processing systems would actually recognize, okay, this image has this part which looks like the Eiffel Tower, so let me classify it as Eiffel Tower. So that's kind of how search by image works too. So you can drag and drop an image of the Eiffel Tower into the image search box, and then it will give you results that actually have the Eiffel Tower. So we again identify that this object is in there and try to get out results. Any other questions?
Point of your view, what's the difference between Google and the other search engines?
I can just talk about Google. I mean, we continuously like work on signals. We innovate. I mean, we actually always kind of monitor our competitors as well. We have our internal quality metrics, so we try to make sure that we are actually staying above our competition. Because in the end, complacency can do this field. IT is like is a field where like, it's just our competitors are one click away. So we can't really be complacent. I was actually giving a talk at HSBC and I was telling them, you guys kind of have some buffer because if I want to change banks, it's a pain. I need to close my account, I need to go open another account somewhere else, I have to transfer my money. So they have like a buffer for being complacent. But for us, there is no buffer at all. It's a matter of somebody just typing bing.com or some yahoo.com rather than google.com into a browser. So we actually have to be on top of things and we need to continuously innovate and make sure that we stay best. So it's the resources we do and the people we have.
What kind of revenue model does the Google search?
So search revenue comes purely from, well, mostly from AdWords. So those are the links that you get on the right hand side or at the top you get it with a yellow background kind of. So those text ads are the ones that pretty much make a buck of the money.
What happens when somebody requests for page, something called Google Cache web pages?
Yeah. So that comes, so I was talking about the crawling step, right? We crawl and we keep a copy of each page. So we have a copy of every page. So it's petabytes of data. So who knows what petabyte is? Yeah, so it's actually, yeah, it's going, but yeah. So we have a lot of data. I mean, we store tons and tons of data. Web itself, we have a lot of data. Like we have Gmail and all these docs, and we have different properties. So in our data centers, there's like tons and tons of data.
Are you implicated in real-time search?
Oh, real-time search. Oh, that was the issue with Twitter, that the agreement expired. So yeah, we don't have data.
People actually because with advertisements display
Last year, it clicked to the worth of $50 billion.
How do we get new Google?
So we are always hiring.
Yeah.
You can go to google.com/jobs.
Does it open for the Sri Lankan market or?
So there isn't an office in Sri Lanka. The closest is India. You can work in India or you can work anywhere in the world. So we normally hire. We don't say we hire for like a specific country or a specific project. We just hire to a pool kind of, and then you can work.
And if we want to contribute to Google Maps, as in adding new points, new places to Google Maps, can we do that?
Yeah, so there is a developer, like a map maker community, and so yeah, there is a. I mean, map maker is free for anybody to join, and then there is a community of reviewers. They will review your changes and they will upload it, and it should be up and visible within like a week or.
And the new Google Map, the new edition of it, does it use the new images or the old images as how it was?
So it's, I mean, it depends. When you say images, what do you mean? Images as in speed bill or?
The satellite.
Satellite. So it's the satellite images, we are always refreshing them. So it's continuous, but Sri Lanka might not get refreshed. But we are always refreshing them.
Yeah. Why don't we give those speeches?
No one will ask about that. We can vote for question.
I'll give you some. I don't have t-shirts. So I had a recruiting talk in the morning and they gave me, recruiting people gave me some stuff, but I saved a bit of stuff in case. Here. Whoever asked the questions actually, yeah. Maybe who asked the questions? Let me, no, I can't actually. So it's an honor system. Yeah. Any other questions? Who else asked questions?
If some of us have some idea, so if some of us have an idea, like one innovative idea or something,
yeah.
So is there any way that I can get support from Google, or that I can go to reach them and say,
innovation is a very tricky thing. So an idea with the innovation is less than 1%. Execution is like the critical thing. So if you have an idea, work on it, try to get a system running, build an app or whatever, and then people will notice you. So like a lot of people have this notion, oh, I have this cool idea, right? But a lot of people have cool ideas and like nobody implements them. And cool ideas don't necessarily make great products also, because I mean, if you take a look, example at even Google, right? Before Google, there was Alta Vista and all. So there was a search engine. So it's not really a new idea, but there was like how it was executed is different, right? So that's what's important. So try to work on your idea, try to get something moving, and then start talking to people. So there is, I think there is an angel investor community in Sri Lanka. So there's venture capital kind of happening in Sri Lanka. So you can actually go and pitch to them. But don't go and pitch an idea, they will kick you out of the room. Always go with something solid.
How does your site search as an angel? You guys have internal site where you can embed your
yeah, so we have
sites, but sometimes I've noticed that I don't specifically get results on my own site only. I'm on my own site.
Okay.
But I have noticed that I get other results also.
So you have a custom search engine on your site and you're saying you're getting other results?
Yes, I have noticed. Not always.
Because custom search engine should be kind of runs pretty much like a site colon on the query in a sense, in some sense. So it shouldn't really return anything else unless you're unless somebody, I mean, is the URL different or the content different? Because maybe some you have like
some other.
That's really odd. I wouldn't be able to answer that without seeing the issue.
I see that that Google is moving more into that founder's phrase, like more of an information company than the website tricking company. Like now all the results, if I like to get the stock results, I don't have to go to a website. The stock results just come there. So in that context, how is the SEO and everything?
So I mean, in the end, things that can be answered easily, we don't want users to, like, if it's a stock quote or something, there's no point going to another site, waiting for that site to load, and then like going and scrolling to the right place and getting it.
So is it moving more towards that? Like
So we are moving more towards answering your questions than giving you 10 links. So we want to, if it's possible for us to answer your question, we want to answer your question. Because in the end, what we want to do is make things easier for the user, right? So if putting that stock quote on the results is going to make it easier for the user, then yeah, we will do it because it's better for the user, right? So that's kind of the direction we're going, trying to reduce the number of clicks that you need to make to get the information.
How long Google could keep our data such as mails and all?
So your mails, you can delete it.
I like it to keeping all my mails as records, but how long we have to keep it?
So we will keep your mail pretty much as long as you keep your account alive or don't delete it, right? I mean, otherwise, because if we delete your mail because we don't want to keep it more than a year, then you get pissed off when you like try to search for something and like flop, and mail is gone. Right? So it's I mean, we have policies on like how long we keep data and all for like search history and all that. But a lot of these search data and all is anonymized, so we can't attribute it to anybody, and there are strict guidelines in the US and all on how you can keep data and all that. So we are like adhered to all these guidelines, and actually we try to go one step beyond the guidelines and actually have our own guidelines and how much data. So we do pay a lot of attention to user privacy, because in the end it's the user's trust that keeps us going too. Right? If the users don't trust us, then they won't come.
The mail is not going to be used for the 10-20 and stuff.
Sorry?
The mail is not going to be used for 10-20.
Yeah, so if it's there, it will be there, but nobody's going to go poke your, like nobody's going to read it on it. Right? So, and the data will be there as long as you don't delete it.
Do you think Google Voice search is pretty much successful?
Voice search?
Yes.
So, I mean, voice search has gotten so much better in the last, like, I mean, iteratively.
It's so because when I search for some like customized queries, it is not up to that search level. It's, if I say my name, Shafran, it says aha.
That might be a mistake.
So it's sort of like, is it like,
so, I mean, there are challenges, right? There are accent challenges, and then there are like certain words that, I mean, if you haven't heard like some, I mean, everything is not phonetic, right? Like, so it's hard to sometimes certain pronunciations. It's hard to figure out okay, what does this translate to. So if you ask like regular English terms, our data set would be large enough that we can actually do a good job. But it's a iterative process, right? As you talk more and more, and as you talk and you fix the word because it was wrong, then that's a cue to us. So you say it, and then it puts like markers underneath it. You can go to a word and then you can change you can delete it and type it again. So we know if you delete it, that could be a signal that's saying, oh, we got this wrong. That's why the person went and deleted it. So I mean, we use a lot of different signals and we try to get data sets, we try to acquire data sets that is both speech and the text, because that's how you learn, right? So these are all machine learning algorithms. That's how you kind of.
Does the algorithm is self-learning?
So it's you have like a training set and it learns from training set, and there are lots of different contexts. I mean, speech recognition is a very big area. There's like a lot of different algorithms and different research techniques. I'm not familiar with everything.
Do you believe that Google Translate give us correct translation?
So in certain languages, yes. Certain languages, it's bad. Why did you get a bad translation? Not what you expected. I mean, again, translate is also like a machine learning thing. You have to have data sets.
If we translate like from English to Japanese or some language, we copy those Japanese language to the other way, it's given us some other way.
So yeah, I mean, it's it might be lost in translation, a bit getting lost, and then if you put it back, the loss is too much to kind of recover from. So yeah, I mean, there are holes in the. It's not a perfect system. We don't say use this as a professional translation. It's just that.
How about Google Space API?
Sorry?
How Google Space API?
Space API. I'm actually not familiar with that. Is that storage API or?
I tried to use it. I
am not really. So I don't really need to.
No, can't really find it so that I would like to implement something called astrological applications.
Oh, you mean this? I have no idea what that API is.
No, that's
Google search would be better off than asking.
Why is it that the Google Map API?
Sorry.
The Google Map, you can find the Google Map.
Yes.
But you can't find the Google Space.
Google Space.
Yeah.
So we are still working on the next frontier.
So I have another one question. So you're from Sri Lanka and you went to Google.
Yeah.
So I'm a student and some of my friends are here and some of them are students and we are new to field. So I'm still in the intern in some company in Sri Lanka. So what's your opinion? What you have? What to tell us?
So I mean. So engineers at Google, so you basically need, the minimum requirement is you need to have a CS degree, be an engineer. So we do hire in like different questions, like we have software engineers in test, we have something called site reliability engineers. Those are the three main engineering questions. And I mean, my advice would be study hard, and I mean fundamentals are very, very important. So something I see a lot in interviews done with Sri Lankans is that they are weak in their fundamentals. Like especially University of Bologna and all, like we've interviewed a lot of people, they struggle with fundamentals a lot of times. So I mean, if somebody is not good in the fundamentals, it's going to be really bad. And we don't really ask like crazy questions. We used to ask these like puzzles and all, but we stopped them like about 5-6 years ago. So we won't ask you any random puzzles. It's going to be a technical interview. It's normally 5 interviews, 5 45-minute technical interviews, and basically mostly to do with data structures and algorithms. Anybody else? Okay, I guess that's it.
Just one question.
Yeah. Go ahead.
Is there a way for us to not have a web page listed on the Google search?
So you just change your robots.txt and say, just search for robots.txt and you'll get like Wikipedia site talking about how robots.txt works. And you can basically do it. dancing, why you have some secret information that you should not say. Okay guys, thanks a lot. I hope you learned something. Yeah, no worries.
To wind up, APIIT has something to present us. So, Sumaya, please.
Thank you.
What's the latest Android ID launched in Google ID? AID. I have to do it as well. Okay, answer to answer that question. You have this. Any others?
I have seriously got bad.
You know, okay. What is the latest language that Google APIIT gives us support? It's an experiment or not? What is the latest language that Google APIIT is So now we can another language. No. Go on. So I'll answer. Language is PhD. You can do it. So how can I get this? Okay. Answer who has been to Google I/O Sri Lanka. Okay, before you go, please disclose your details to the team, okay? And finally, I would like to thank Nayana for coming here. I know it's not full-time work from Sri Lanka, so I know anyone in your mother tongue you need to be with your loved ones. You came here for us. Thank you very much. And Rohan, I think he's now ready to give coming here. And Bhagya for the great insight for the here. And really, I really want to thank APIIT for giving us the chance to host the event in APIIT, Sri Lanka. Thank you very much. And you all for coming here for this event. I hope you will all come to our next meetup as well. We'll announce it to our Google page. You can Google Plus page. You can go to Google Plus and search for DD Sri Lanka and please circle our page as well. Thank you very much.